So I want to start by telling you about a game. It's called Game Dev Tycoon. Can you raise your hand if you played this game before, any of you? Okay, cool, got some fans. It's a really fun game. It's made by a developer called Green Hut Games. You play as a game developer, and you release games, you make a profit, you can then invest that profit in bigger offices and making consoles and so on. It's a lot of fun. This developer came up with a unique, novel approach to piracy. They actually released a cracked version of their game on pirate sites at launch. What players didn't know that in this cracked version, your games would actually suffer from piracy every time you released them. It would really be a drag on your in-game experience. You wouldn't make money and you wouldn't be able to progress. It became really, really hard to actually complete the game. People who downloaded this cracked version, they weren't aware of this, and they started flooding the forums saying, why am I suffering from piracy in the game? Like, it's killing me, it's killing me. And without a hint of irony, these people who had pirated the game were complaining about piracy. Some of them were even saying, can't you add DRM? Like, how do I protect my game? How do I fight all these pirates? So I thought this was a really creative approach. Sadly, the game was still really widely pirated. The developers saw 95% of their players playing cracked versions. And Patrick, the CEO at Green Hut, was pretty disheartened by this. He expressed this sentiment. This was a few years ago now, but he felt that piracy was one of the reasons that single-player games were sort of moving towards more of a freemium model and away from these kind of single-player immersive experiences. And I don't think Patrick is alone in feeling this way. As a gamer myself, this makes me really sad. I really enjoy single-player immersive experiences. I want these types of games to also thrive on Android and Google Play. And that's why I'm very excited to be here today, because I'm personally passionate about this area, and I get to talk to you about it. My name's Dom. I'm the PM for a new team focused on app and game integrity here at Google Play. We're working with lots of other teams around Google to ensure that Google Play is a trusted and safe ecosystem. So I'm going to talk about the features and services we're investing in to help you protect your games and your players. I'm passionate about Google Play being an ecosystem where all different types of business models can thrive, from freemium to ad-supported to subscriptions, and indeed for premium games too. So first, I want to quickly touch on some things we're doing on the platform side, so you may be aware of some of these things. Google Play Protect is on every Android device, and it scans 50 billion apps and games daily. It catches over 99% of malicious apps and content on devices. We also continue to strengthen our policies to reduce the number of malicious apps on the store. Last year, the number of apps and games suspended increased by 66%. Now, this is actually a good thing for users. We're reducing malicious apps on the store, and it's a good thing for well-intentioned developers, because if you're a well-intentioned developer, you want the ecosystem to be trusted so that users can get your Apple game. And after hearing from users and developers as well, we've continued to evolve our policies for family apps and games as well. So we recently announced some changes if your game targets families or kids. So you should read about those online. Play Protect is great. It works out of the box, but it doesn't solve all the problems that you probably have as a developer. So I want to talk about tools that we're developing to solve a much broader range of problems. Protecting your games can mean many different things. I'm going to focus on 3 areas. Integrity. Does the game binary and the device do what you actually expect it to do? Fairness. Is the in-game economy fair? Are players getting an unfair advantage? And security. Is there malicious traffic, malicious actors out there trying to attack your game? So the first thing I'm going to talk about is integrity. When you have a popular game out there, it's going to attract bad actors, people who want to cheat, people who want to take advantage of other players, who want to hack the game. Often these attacks can happen from modded APKs, they can happen from rooted devices, they can happen from pirated APKs, emulators, things like this. These aren't necessarily bad vectors in themselves. They're not intrinsically bad. They're just often the launch point for attacks. So as a game developer, you want to make sure you're identifying these vectors, and then it's up to you how you might want to act on them. For integrity, we have two solutions which we offer today to developers to help you with this. We want to help you answer two questions. Firstly, can the game binary be trusted? Secondly, can the device itself be trusted? The two questions go together because if you ask the game binary and it says, hey, yeah, you can trust me, it's fine, if you don't check the device integrity, there could be something funny going on. The device could be spoofing that check, or it could be trying to tamper with it. So for the first part, can the binary be trusted? We have the Play license verification library. For the second part, can the device integrity be trusted? We have the safety net attestation API. So you have a game. You want to find out if it was downloaded from Google Play. Your game calls the licensing API, which reaches out to Play's license verification server. And it asks, has this user got the game from Google Play? Assuming it says yes, the verification server returns a valid license. Here we go, which returns a valid license, which triggers a callback telling you, yes, this user has got the game from Google Play, and then you can let the player into the game. But suppose that the user doesn't have a valid license. Maybe they got the game through an unauthorized distributor, or they've sideloaded the game. Then the server will return no license, and then you can choose how to react to that in the game. You can require them to log in, or you can block them from accessing the game. OK, that's the license check. The second thing is safety net device attestation. This is a little bit more complicated. You have to check. You're checking to see if the device itself has integrity. So you have to trigger this from the server first. Safety net works really well for intrinsically server-based games where you have lots of server calls. So I'll talk about other types of games which are predominantly offline in a second as well. So in this example, Supercell's Brawl Stars, this is very much a server-based game. So Supercell's game backend initiates the check here. They send what's called a nonce into the game. A nonce is a small, unique ID that you associate with every single check. And I'll explain why you need that in a second. Your game makes the API call to the safety net attestation API, and it attaches this nonce in this request. This is forwarded to the Google attestation backend. Now, the backend has lots of different signals. We use lots of different signals from the device to make a call as to whether or not that device has integrity, to check that it has passed CTS, that there isn't anything funny going on with the device. So we'll use those signals, and then we'll send back a response about whether or not you can trust the device. The safety net attestation API forwards that response into the game, again with the nonce attached. And your game can then forward this back to the server. So in this example, if you have a valid attestation and the nonce which you sent from the server matches, then you know that that whole chain can be trusted and has worked. The reason you have the nonce is to protect against what's called replay attacks. Because if you just get a valid attestation back from the device without the nonce, then the device could be faking that call and attempting to say, hey, I'm fine, but you don't know that. But you sent that original nonce, so you can trust the call. Assuming everything works out OK, you can let the player into the game. So how does this work in real life? I want to tell you about some examples. So Rovio have a very popular game called Angry Birds 2. They have a global leaderboard in the game. And as you can imagine, with millions of players, people are motivated to get on that leaderboard. And not everyone is doing it through the skill of playing the game. There are people out there who try and attack and hack and cheat their way to get up the leaderboard. There are two main ways of attacking the leaderboard: modded APKs, which people were sideloading, and memory attacks on the device. And these can only happen on rooted devices. So safety net was a This was a perfect use case for safety net here. So Rovio implemented the safety net attestation API, and the results were really good for them. After 30 days, there were 40% fewer players on untrustworthy devices. And these were the devices where they were seeing the hacks come from before. So that's shrunk the pool of possible attacks that are happening on their leaderboard. And to bear this out, they actually saw a much higher percentage of paying players in the leaderboard afterwards, of high-spending players. They were really happy with this result. It made the game fairer, it helped the game, it helped the leaderboard, and so overall it helped the community. A second example I want to talk you through is about reducing beta leakage. So what is this? This is when a game will want to soft launch a beta in a limited set of countries. This is a best practice of launching your game. You can get information about your players. You can figure out how many servers you're going to need to launch. You can figure out like behaviors of your players and things like this. Beta leakage is when people rip the APK and they play in countries which you didn't intend to launch in yet. And this can mess up all your numbers. It can mess up your analytics. You don't know how your actual real demographic of players is going to act. You don't know how many servers you need and things like this. One partner we worked with saw a real issue with this. On a previous Android soft launch, they saw, because the servers are still supporting these players who ripped the beta, they saw 90% of the players were unauthorized, were from countries they weren't doing the soft launch in. So the challenge for you as a developer is how can you stop a soft launch from unintentionally becoming a global launch? And this is where app licensing and safety net come in. So because sharing of the beta launches in unreleased countries, normally the users have to sideload that APK to install it. So the license check won't fail there because the license check will fail because they haven't got the app through Google Play itself. And then, as I mentioned before, safety net lets you trust the device integrity and lets you trust that license check is genuine. Now, what was the result of this? So Supercell wanted to control the distribution of Brawl Stars during their beta testing. With a combination of licensing and safety net, they saw a significant reduction in unauthorized players. On a previous beta launch, they saw 90% of players, unauthorized beta players. With this combination, for Brawl Stars, they saw under 50% were now unauthorized beta players. It was a huge, huge improvement for them. They were really, really, really happy with this result. So these two pieces of technology together have many more use cases beyond, but see, they straight away helped in this scenario with beta leakage. So those APIs can be significant work to implement really well in your game. They work really, really well if your game is intrinsically server-based and has server calls. But what about other games? What about paid games, offline games? If you're a small indie dev, you might not have your own server backend. You might not have the expertise to do this complicated integration. So we want to help there as well. We have a new integrity protection EAP that you can join. And we will actually automatically add checks and protections into your game. So if you're interested in this, talk to your partner manager. That's integrity. The next topic I want to talk about is fairness. So this is about ensuring that players don't get an unfair advantage in your game. Some problems here can be addressed by strengthening the integrity, but there are other types of cheating that can go on, particularly around the in-game economy. So I want to talk about those now. These are some of the problems that developers struggle with when it comes to keeping their games fair. Abusers use all types of methods to try and manipulate in-app payments and purchases to try and cheat in the game. This is bad for you because cheaters can ruin the game for other players, and cheating actually can hit your bottom, hurts your revenue too. So I'm going to talk about two solutions we have to help in this area. The first problem we want to help with is about fraudulent purchases, and this is where Google Play billing can actually help. The second is, can you detect when purchases have actually already been refunded in your game? This is where voided purchases can help. These two protections work together because we see a common attack vector as follows. An attacker will make lots and lots of purchases of in-game items, and then they'll sell them to users on the web or outside of the game. They'll sell them very cheaply. And then they'll try and game the system by coming back to Google Play and getting those items refunded. And then when the people who they sold them to will then go and try and use their in-game items. And they might not be doing that maliciously, but that's then impacting your game negatively. So we want to help with both ends of this funnel. So Google Play has a way for you to check each purchase to see whether Google thinks that it might be fraudulent. You may have heard this being referred to as Caragander, its project name. I'm going to walk you through how it works now. You add the player's ID to each purchase request. So these are labeled here as account ID and developer ID. Account ID is the player ID you use in that game, in the game for the player. Developer ID is if you have a separate ID for this player across multiple games. So if you only have one game, these two IDs will be the same. Google's risk engine will then use these IDs to make an assessment of whether it thinks this is a fraudulent purchase and can actually block fraudulent purchases in your game. So this Google Play billing feature has been adopted by 20% of top partners already. We think it will help a lot more of you. Partners have seen really positive results, up to 30% decrease in fraud attempts from this. And it's led to as much as a 50% reduction in chargeback losses, too. The voided purchases API is also pretty simple. At any time, you can request Google Play to give you a list of in-app purchases which have been refunded. You can then use this to update the player's inventory and remove refunded items or make other changes to the player's experience. The results of integrating the voided purchases API have been really positive. Over 80% of top partners are using this API. And some partners have seen up to an 80% reduction in how much they've had to refund after implementing this. The benefits go beyond reducing refunds. It also helps reduce abusive behavior in the first place. And we have some best practices you can see here in your game. So what's next for refunds? We're also testing an early access program with some developers. So for games in this EAP, when Google Play gets a refund request, we'll actually pass that information to you, the developer, with the refund reason. You can then tell us about the status of that item, whether or not it's been used in the game or not, and you can give us a recommendation for how Google should act on that refund. We'll then take that information and we'll make a refund decision to the user. So this is really useful. You can then tell us if the item's been used or not, or maybe the item was never delivered to the player in the first place. This helps us make a more informed refund decision. This can help us actually also detect when people are perhaps requesting a refund after they've already used the item. So this is better for in-game. So cheating is bad for players. It's bad for the player satisfaction, and it's annoying for the community. But the next topic I want to talk to can take things to a whole nother level. If an attacker injects malware into your game or starts stealing player data, then this can be a much, much, much more significant problem, which is why the security of your game is something which is really important that you need to focus on too. So security attacks come in many different forms. Lapses in security can harm your users. They can result in really negative PR, and they can result in massive fines. This is a regulated area, so this is a really significant risk to your game too. So it's really important to have strong security processes and to find and fix vulnerabilities as they appear. I'm going to focus on 3 approaches to strengthening security. First, how do you get better at finding and fixing vulnerabilities? Second, how can you continually improve the SDKs that you have in your game and make sure you're not at risk there? And third, how can you attempt to detect and reduce malicious traffic coming to your game too? So finding and fixing vulnerabilities is hard. It's probably not your expertise as well. You want to focus on finding your game. So that's why I can actually recommend outsourcing this part. Google Play has a bug bounty program. So if you don't know how that works, you can opt your game into the bug bounty program, and Google Play will actually pay security researchers who responsibly find vulnerabilities in your game and report them to you. We'll actually give them a cash bounty reward for doing that. So we have a lot of app developers in this program. We want to get game developers in it too now. So I recommend signing up to this. We've paid out over more than $50,000 to security researchers for this too. Next, I want to talk about SDKs. So it's important to keep in mind that you're responsible for all of your game's content, including third-party libraries and SDKs, and often these actually can make up the majority of your code of your game, and you didn't even write it. So with that in mind, I want to remind you of some important SDK best practices. You should always ensure you do a thorough review of every SDK that you integrate into your app, into your game. You should review the data and device information it collects. You should appropriately display that to users and get consent, and you should make sure that SDKs only access that data after you've got consent. Google Play has had to suspend games in the past for what SDKs have done in the game, and the game developer has not necessarily realized. So we have a Play Academy course online here to help you with some best practices for your SDKs too. We're actually, this year, as you heard in the keynote, we're raising the bar for SDKs a priority for Google Play this year. So we started working more closely with SDK providers. We're going to help them improve the quality of their APKs, and we're going to bring more of that information to you as a developer so you can pick the right SDKs and make a more informed decision. So stay tuned for more in this area. Finally, there's one more security-related API that I want to talk about. Some attackers use bots to attack your game. You know, they might just be trying to cheat, or they might be doing it for more malicious purposes. They might be trying to bring down your servers. The safety net reCAPTCHA API can help here. You're probably familiar with this from the web. You may have seen it. So when your game loads up, it can call the API. Google's reCAPTCHA risk engine can make an assessment about whether or not it thinks that is human traffic or abusive traffic. And if it thinks it's abusive or a bot, it can present a CAPTCHA, like a simple challenge for a human to fill out. It's harder for a bot to fill it out. And then the player, once they complete this, is allowed into the game. So some developers I've spoken to want more control over this, though. They don't necessarily want the challenge showing up in the game. So if you've been waiting for more control, I can actually tell you we have a new option for you as well. We're testing a new feature for reCAPTCHA, which gives you a risk score. So you can actually just make a decision in your game. This is part of a new enterprise offering from reCAPTCHA. It doesn't have to display a CAPTCHA anymore. Instead, it will pass you a risk score between 0 and 1. 0 for abusive traffic, or 1 for very likely human traffic. And then you can decide in your game how you react. Maybe abusive traffic, you require an additional challenge, like two-factor authentication. Or for consistently abusive traffic, you could actually change in-game behavior or in-game items too. So this is part of our reCAPTCHA enterprise offering, and it's a paid service with the full support and SLAs that you expect of an enterprise product. So if you're interested in this, there's a sign-up form on the web, or again, just talk to your partner manager. So today, I've covered very quickly a whole range of features and services that we're investing in this area and continuing to improve. These is to help you protect your game and players. So licensing and safety net are about strengthening the integrity of your game. You can ensure there's fairness of your in-game economy using Google Play Billing and using the Voided Purchases API. And with the Google Play Security Rewards program, you can actually get Google to pay for helping find vulnerabilities in your game. We've got new best practices for SDKs, and we're going to be sharing more in this area. And reCAPTCHA can help you identify and prevent malicious traffic from getting in your game too. I'd like to chat to you afterwards if you're using any of these successfully already. And if there are problems that you're seeing which we're not helping with as well, I want to hear about those as well. Thank you very much for your time.